So when we talk about item analysis, this relates back to, again, classical test theory. So with classical test theory tends to focus on the test as a whole. It's looking at the reliability of the test, the validity of the test, but knowing what we know about things like Cronbach's alpha and those types of things and how that works with inter-item reliability, we can also start thinking about things at the item level as well, like how well do items work, and can we choose better or worse items depending on some characteristics. So when we talk about item analysis, these are methods used to evaluate test items, like which items are good, bad, and there's actually different ways of thinking about that. It's not just one answer to good and bad. There's a couple, at least two different ways of thinking about it. We got, which are these two, the item difficulty and the item's discriminability. And the weird thing about item difficulty, it's called difficulty, even though the higher the number is, the easier the item is. So it really should be called item easiness. So it's the name is a little bit misleading. Higher scores typically mean that the item is easier. So the fact they call it difficulty is sort of confusing. But that's just how it is. Discriminability has to do with the item's ability to discriminate between people on using the scale. So if you have a depression inventory, you want your items to be discriminating in terms of the item that people are answering. If I answer yes to an item, that means hopefully I'm on the upper end of depression. If I answer no, I should be on the lower end, and the items are able to discriminate against people on the two different extremes. Okay. And we'll talk about a couple different ways of looking at discrimination. One is called the sort of extreme group method, which sounds a lot more crazy than it really is. It's taking, if you cut your respondents into thirds, look at the upper third of respondents, the lower third of respondents, and look at the number of people who endorsed an item, then you can see the difference between the extreme groups tells you how discriminating that item is. People on the high end should endorse the item at a lot higher rate than people at the low end. So we'll talk about that in a minute. And then this one's actually really cool. It's an interesting idea that if an item is discriminating, another way of thinking about discrimination too is if an item discriminates well, it means that it actually relates to the construct very well. So if I have an item that's very discriminating on a depression inventory, and it's able to tell people who are highly depressed from people who are very low on depression, that means that item it also means that item is highly related to depression. It actually is able to capture depression really well in one item. So we can actually look at things like item total correlations. So I take the total of all the items on a scale, like add up all the depression items on a scale. I can then correlate each item with the total, and those items with a higher correlation then are more discriminating than items with lower correlations. We can also combine the two of these, the difficulty and discrimination, in something called an item characteristic curve, sometimes referred to simply by ICC. The ICC for each item, we can actually look sort of descriptively or graphically at both difficulty and discrimination of each item. And then I'm mentioning this here, but we're not actually going to get into it. We can actually talk about item response theory, and with that also item response theory and factor analysis. Both are ways of looking at the item's quality. Factor analysis tends to focus only on discriminability. Actually, in a typical factor analysis, it only looks at discrimination in the form of loadings, which we'll talk about next in the next section. Where item response theory looks at both difficulty and discrimination together, but they both are similar types of ideas. We're going to go into this in a little more detail. This one we're not going to cover. And in using things like criterion reference testing is actually easier to look at sort of item analysis, where normed ones are a little more difficult. Criterion reference testing is, you can do a thing like a item total correlation, because if the criterion, say, is PsychTesting, and it's your midterm, if you look at an item that has a high discrimination, well, that one item is very predictive of someone's overall PsychTesting knowledge. So criterion reference testing works sort of better with item analysis, even though you can do it with norm reference testing. It just becomes a little bit of a different process, a little more complex. Questions so far? All right, so let's talk about item difficulty. The proportion of people who get a particular item correct or that endorse an item, right, if there is no correct response. Okay, so we got to think about this. The language that was developed for these things is out of sort of education, aptitude, achievement type testing. So when they talk about the proportion of people who get a particular item correct, that doesn't really apply to social psychology or to social sciences, specifically psychology. We don't have a lot of like items where we think about them as being correct or incorrect, right? They're and the MMPI, if you say, you know, I like what's one of the weird items? I like car magazines. I think it's an item on the MMPI or something like that. I like car magazines, and you say yes. It doesn't mean you got it correct. It's not. There's no correct or incorrect. So we oftentimes will think about sort of endorse the item. So endorsement becomes a replacement for correct, even though with words like difficulty and that kind of stuff, it really still sort of harkens back to this idea of correctness. So if there is no correct response, then we say, okay, well, what's the likelihood someone will endorse the item? Easier items have more endorsement by participants. More difficult items have less endorsement. So like on a lot of depression inventories, questions about suicide ideation or suicide attempts, that sort of thing, tend to be very difficult items, right? Not because more people, you know, don't get them correct. It's because few people actually endorse those items, even if they're high on the other items on the scale. There's still, you know, a pretty low chance that they'll endorse the item asking about suicide or suicide ideation. So those tend to be more difficult questions, but they're not correct, even though we'll use terms like correctness or something like that. It's just a weird fit. And like I said before, it's often thought of as the item's easiness because it's based on the number correct or the number endorsed. So the higher the number is, the larger the proportion, the easier the item is. So as the proportions go up, the item gets easier. So it's just odd that we call it difficulty when difficulty is on the low end and easiness is on the high end. Okay. We can even convert the item difficulty into a proportion form. It can be standardized into a z-score using this equation. This is like the natural log. This is the proportion of the item. So we can actually put it on a scale, because the problem with probabilities or proportions is that it's not linear. There's, you know, it's a funny scale, because going from 10 to 20%, for instance, sort of doubles, but going from 20 to 30 is not double, right? So it's not a linear shift across the scale. So what this does is it sort of takes the proportions and sort of stretches them out, so you get a nice linear comparison. You can actually look at how people are differing across the scale in a linear way as opposed to a curvilinear way that's typical with proportions. So I'll give you an example. For example, a test with a difficulty of 0.84. Actually, it really should be an item, but whatever. You can actually take the log of 1 minus that 0.84 minus the log of 0.84 over 1.7. And you're probably asking, why 1.7? It's a scaling factor, and I forget why it's exactly 1.7, but it has to do with the relationship between the curvilinear proportions and the linear ones, and 1.7, because 1.7 comes up a lot in IRT as well. It's a scaling factor in IRT, and it has something to do with taking curves. Proportion curves look like this typically. Right. And it's a scaling factor that's somehow related to when we use the z-score methodology. It actually sort of stretches the proportions out into a linear function, and that 1.7 has something to do with the metric for doing that. I don't remember exactly why it's 1.7, but it's something about how it gets about the transformation process going from curve to linear. When we apply this, we get that this item with 0.84 is a -1, and typically it goes from sort of -2 to 2 is a typical range of sort of difficulties. Where here I think it's been reversed, where because 0.84 is a pretty easy item, 84% of people are endorsing it, it actually gets flipped around. So now the negative indicates that it's easy and it's more difficult with the positive values. I think it gets actually flipped around that way. Because right around 0.5, it's going to be roughly 0, because the log of 0.5 minus the log of 0.5 is going to be 0 over 1.7. So yeah, I think it does flip around. So it actually makes it more into a difficulty scale, where higher numbers mean the item is more difficult by doing it that way. And this is really just about convenience in terms of taking a nonlinear function, converting it to a linear one, so that it's actually easier to sort of compare and see where people are on the scale, how far apart they are. So if you look at this is just some examples from the midterm. These numbers are not based on you gals, because there's only 5 of you, so it's sort of hard to gauge the proportion of endorse and that kind of stuff. But if you're taking a criteria reference test in a social psychology course and you need a score of 92 in order to get an A, the criterion is, so the answer was social psychology. This is a relatively difficult item, mainly because the distractor scoring a 92 is likely the most probable wrong answer. Meaning that a criterion reference test in social psychology course and you need a score of 92, if you thought 92 was the criterion, then you would put that answer as the correct answer. I think so this distractor actually ends up being a fairly attractive distractor for a lot of folks. But the criterion we're talking about is the domain, the actual thing we're measuring, which is social psychology. So this is a fairly difficult item with only 35%. This is in 2000. It's been a few years. It was a class a few years ago. Only 35% of them got this item correct. And if we actually switch that around, we can actually say, okay, well, how difficult an item is this? So when we actually convert it over to this sort of linear scale by putting through the z-score metric here, we get that it has a 0.364 difficulty. Again, so it's now on a positive end, so higher numbers, more positive, meaning it actually is more difficult. And again, by itself, this isn't super useful, but if you try and compare across a number of items, you can start to see which items are more or less difficult depending on their z-score. So here's a sort of moderate item, basically 50-50. The correlation between x, especially x and y, is 0.54. I don't know why the y is missing. X has an SD of 1.2, y has an SD of 5.4. What's the regression coefficient when y is predicted by x? So the answer is 2.43. I don't know what the distractor is that it's sort of attractive here, but so at that semester, half the class essentially got this item correct, the other half did not. And we can convert that over, and you start to see, again, right around a half, right around 50%, you start to get in the center of this distribution. So it's slightly above 0.5, so it's right around 0, but it's on the negative side. It's actually just this side of difficult as opposed to easy. Right. Here is a easy item. So when I ask this question, for the following set of data, the mean is, and I think 100% of the students got this correct. So it's an easy item. And for items that are 100% correct, they're so easy that everyone gets it correct. You can't even calculate the z for it, because when you take the log of, so 1 minus 1, is 0. And the log of 0 is not a number or whatever. So when you try to work this out, you end up getting an error. Okay. It's like extreme. You can't even calculate the most extreme easiness because it ends up being sort of something you can't calculate with the natural log. So the takeaway here is not necessarily the z stuff. It's just this idea that as percentages go up. So this is a difficult item because the percentage of correct is low. It's on the low end of 50. This isn't even that difficult. It's not like it's 0.1 or something where very few people got it correct. And oftentimes on a test, I'll go through and look to see for item difficulties that are that bad, where it's like only like 10% of the class got it correct. I'll go look to see if I didn't score it incorrectly or something wrong with the question, because I usually don't have questions that are that difficult. That's too difficult, because they're not very useful. It's only going to help me with 10% of the class. It's not super informative. So this is actually a fairly decent, 35% is a pretty good difficult item. It's not too difficult, but still on the difficult side. As you go up to a 0.5 item, as the probability has gone up, it's an easier question. As the proportion goes up even more to 100%, this item is the most easy you can have, because it was so easy that everyone got it correct. And usually that also tells me something. Either the item is just really easy, or there's something about it that gave the sort of question away, which happens sometimes. Or I forgot, there was an exam one time where I gave a question about something, I forgot what it was, and then the very next, or a couple questions later, it had a similar setup, and it actually gave away the answer to the previous question. It was something like, what's the mean of this? Right? And then a couple of questions later, it was the same data and said, assuming the mean is blank, what's the standard deviation? So it actually gave them the mean in a different question. So everyone was able to go back and answer the question correctly, 100%, because it was right there. So this oftentimes will also tell me there's something potentially wrong. But not always. Sometimes we'll go and look and say, well, it's just something that the student in the class, this is something that either has been ingrained in there and people learn it really well, or it's just a concept that was covered well and everyone sort of understands it. So what's the optimal difficulty? Well, mathematically, you want something that is somewhere between chance and 100%. So that's not very informative. But let's say you have 5-choice tests. So 5 choices means that chance is about 0.2. Right? So if you're just guessing at answers, 0.2 is about your chance. So that's what this is. Find halfway between 100% and chance. So all right, I'm taking 1 minus 0.2, so 0.8. Why do I divide it by 2? 0.8. Oh, because it's about halfway between there, so 0.4. Add this value to chance alone. So this is about halfway between chance and 100%. You add that back to chance alone, you get about 0.6. So 0.6 is somewhere about the sort of optimal difficulty you'd want, optimal easiness. So 0.2, because if you have 5 choices, you have about a 20% chance of answering the item correct, just by guessing alone, right? So alternatively, it says chance plus 1 divided by 2, the optimal difficulty. So if you find sort of this optimal, you want to then, okay, plus or minus a half or something right around here is the sort of optimal range. Realistically, it's sort of goofy to think about trying to make all your tests have the same difficulty. What you really want is a range. You want some easy questions, you want some difficult questions. So a good test will have difficulty values that range somewhere between difficult and easy, but not too easy, and difficult but not too difficult, somewhere in here, to sort of get people to sort of be able to differentiate between one another. So the students that really have mastered the material are going to do better with the more difficult questions. And students that have studied at least some will actually do well with the easier questions, and those who didn't study at all won't even get these correct. Okay, so you actually want a variety, a range of items on a test. So usually when especially when before the pandemic stuff and everything was online, I used to use these sort of test scoring, not a service, but it's like basically a program that works with a scoring machine and stuff that would tell me, it could actually report back to me what the items difficulties were and that kind of stuff, so I can get an idea of how well I was sort of hitting the mark of sort of having a range of items between difficult and easy. All right. Questions about difficulty. So difficulty is a weird thing to think about in psychology or in social sciences in general. It doesn't necessarily mean the item is hard or difficult to answer, like you either know it or don't know it. It's harder because fewer people are going to endorse it. So you have an item that's difficult because it's a statement or a question that's really targeting a smaller proportion of people who are going to say yes to it. Again, like I mentioned, like answering a question about suicide, like have you ever thought of committing suicide, or like I have considered suicide as a statement. The item's not difficult in the same way that a question on a math test is difficult. It's difficult because even people who are depressed are gonna be less likely, a lower probability they're going to answer that question or endorse that question or answer it in the affirmative. So it's difficult because it has a low rate of endorsement. So it's a different way of thinking about difficult. It's not difficult in the way you think about a test question being difficult. It's a slight difference. But yeah, this is based on just the proportions. The reason why you look at the z-scores is not necessarily to make these kind of decisions, but to put it on a continuous scale. Because even going from 0.3 to 0.7 is not continuous. So the z-score part of it, I'll actually show you why we do that in a minute. What will be the point of putting it in these metrics? Is to be able to compare them in a way that is linear. Because with the proportions and difficulties, the way that we're talking about it, like the 0.3 to 0.7, it's based on looking at item characteristic curves. If this is, the chance that you're going to say yes to the item versus no to the item, or get the item correct, or endorse it, or whatever the term you like. And this is something like depression as a whole. This is the trait that we're interested in trying to measure with this item. What's going to happen is it's going to be this sort of curve, like down here. If you're at the bottom of depression, you're not very depressed at all, you're likely to endorsing this item. It's not very high. Right? It's close to 0, or it is 0. And all of a sudden it's going to start to go up and curve back around. So when trying to tell the difference between people and their depression level and whether or not they'd answer this question or endorse this question becomes hard, because you're trying to compare changes in probabilities that are not constant. There's actually an acceleration that is occurring, acceleration and deceleration that's occurring in both these places. So it's hard to know. It looks like the best place to discriminate between folks is somewhere in here. Actually, I missed it a little bit, somewhere in the middle. Because these folks in depression are actually, you have the most discrimination against, because I can tell them apart by very little changes in depression. The problem with this is because it's a non-constant change. These conversions over to z-scores will change this so that it's still depression on the bottom. This now becomes something more akin to like a z-score, -3, +3, with 0 in the middle. And you can start to see what the constant changes are in z-scores around the same change of depression. So as you go, up a unit in depression overall, the likelihood you're going to endorse this item goes up by a unit in z. So people like to convert it over to avoid the non-linear function, and we talk about change in this item relative to the trait you're trying to measure, and using a scale that is linear. It's just a way of converting. The term is called it's like a linking function. we can link probability to Z and make it something that is linear and continuous. Just like with this item, now that it's in a, if I know where people are and we can give them Z scores and stuff on this, well then I can use this in things like regression and stuff where the 0 to 1 and these changes in proportions don't really fit in with like linear regression things because they don't change in a constant way. So that's a little bit beyond the course, but these ideas that you can sort of convert this over and you get these sort of -2, actually I put -3 to +3, but -2 to 2 is a typical range. And the main thing here, the main takeaway from this is that by doing this, you're converting it into something that really fits the idea of difficulty more. Higher numbers, positive numbers, mean the item is more difficult. Negative numbers mean the item is easier. Where in its original form, higher numbers mean easy, low numbers mean difficult. So it's sort of backwards. This sort of helps to flip it and make it seem to fit the idea of difficulty a little better. You're not talking about changes in the Z of probability or whatever, the converted form. This isn't it, but there is something called a logit that we use quite often to convert these curvilinear functions into linear ones. So it now becomes changes in depression relative to changes in the log odds or the log of the odds ratio. This is sort of that, but with this sort of conversion factor to sort of make it fit this scale a little bit better, a little easier interpretation. But it's no longer changes in probability anymore, it's changes in the Z. And what's cool about that, though, in a way, is that I can look at, if I look at two different people with different levels of depression, I can look at the differences in their probability. Like, let's say if someone's here, right, and someone's there, I can actually look at the differences in Z-score and say, all right, there's a difference in the Z-score for this. So let's say a delta for Z, right, change in Z. Or I can use this same thing then to convert that back to see, well, what change in probability would that correspond to? By treating it as a linear constant sort of change function as a Z, I can still convert it back and look at how that would relate to a change in probability by converting it back using a similar equation like this. These are just sort of things we do to play around to make things fit into the nice linear functions that we were used to. It depends on what it is what your goal of this whole thing is, right? If you're really trying to compare folks, and you can talk about probabilities, you can talk about changes in percentages and that kind of stuff. It's not a big deal. If I'm trying to use this item, say, and I want to be able to take something like someone's anxiety score and predict this as an outcome, then converting it over to a Z-score like this becomes much more useful because we're used to dealing with linear functions, being able to take regression equations, predict linear functions, linear continuous and linear outcomes. So then we got to use something like this, some kind of conversion to be able to do that. That's all this really is. So and this is just sort of, again, nice in terms of putting it into a metric where difficulty is positive, and the higher and positive an item is, the more difficult it is, where in the original scale it's the reverse. And somewhere around 0 tells you that it's about the middle of the road. It's like neither difficult or easy, it's sort of in the middle. Negative numbers now are easy, positive numbers now are difficult. That's one sort of positive in terms of interpretation. But discriminability can be defined in two ways, like we said before. How well does each item distinguish between individuals who are scoring high and low on a test? Whatever trait of interest you're interested in. So we always say test, but again, that's sort of language out of educational testing, aptitude testing, when really we're talking about scales or traits like personality or depression or something like that in the social sciences. So how well does each item distinguish between people who are high and low on that trait, or simply how well is each item related to the trait itself? So you can think of that in both of those ways. How well does it actually tell high and low people apart, or how well does the item just relate to the trait itself? So 1 and 2 are really the same. Like the more an item relates to the trait, the better it can distinguish between high and low individuals. So they're the same, but they do allow for different approaches to how we test for discrimination. All right, so the extreme group method. You're going to identify two extreme groups. Usually, the most common way is just to look at the top third and bottom third. So you use a program or something to put everybody in order in terms of their total score on the scale, and then you create groups, and then you compute difficulty for the top group, meaning you actually look at how many people in the highest group endorse the item, the proportion. You look at the proportion of how many people in the lower group endorse the item. And if there really is a discrimination, if it tells the extreme groups apart, more people in the high group should endorse the item and less people in the low group should endorse the item, or other way around, depending on what it is, I guess. So depending on how you're measuring the traits, there should be a difference between the proportion of endorsement in one group versus the other. The second is that's the second step is you compute the difficulty in both groups, compute the difference between the top difficulty and the bottom difficulty, and the result then for each item is called the discriminability index. And it tells you sort of a range of discrimination these items have. So I just took a bunch of items from the MMPI. These are interesting. The MMPI has a lot of interesting questions, or statements, I should say. And these are all just yes/no endorsement sort of items. So I prefer to pass by people I know. I'm a very social person. I like to go to parties and other affairs. Oh, these are all from these are social. This is a scale that measures sort of social skills or social ability or socialization for people on the MMPI. So you got like, it makes me uncomfortable to put on a stunt at a party. I find it hard to make talk when I meet new people. So some of these things are worded oddly. I wish I were not so shy. In a group of people, I would not be embarrassed. All these different questions. So what I did was I look at the number of people. 29,356. This is a huge data set. So of those total, so I split it up into the highest third and lowest third of the total people. So that's based on the total score. I figured out the number of people who actually endorsed this item. So about 56%. And in the lower third, figured out the number of people who endorsed the item was only about 6%. The difference is about 50%. All right. So the difficulty here is about 0.5. This actually says percent, but it's really proportion. Look at the ones that are the most different. I'm trying to get my own face out of the way. So here's the item that is the most discriminating between the highest and lowest on this sort of social anxiety scale. So here, at parties, I'm more likely to sit by myself, or I forget, it's something like or avoid other people or something like that is the what comes after the or. So of the highest group on this social anxiety sort of scale here, 85% of them endorsed it, but on the low end, only about 7% did. That difference tells us that this item is the one that's most related or the most discriminating when it comes to social anxiety. This one item tells us the biggest difference between the highest and lowest groups. Okay, so that has the highest discriminability index. Which one has the lowest? Down here. So the lowest, I can't see where it is this one? I'm never happier than when alone. Right? That's a pretty extreme version of sort of being sort of isolated and wanting to avoid people at all costs, in all situations. So if you look at that one from at the top group, only about 20, these are people that endorsed a lot of these social anxiety items. So the people at the top of this, only 24% of them endorsed it. So that's very difficult, even for people who are high on social anxiety. Where at the bottom, only 2% endorsed it. So this has a very low discrimination. It's often, I think it's because it's actually, even for people who are high, it's still a very difficult item, meaning that very few people actually endorse it because it's a pretty extreme view of sort of social anxiety and social isolation. So in that case, this one is, there does seem to be sort of a floor effect. Everyone's sort of on the low end on endorsement. So even people who are high overall still don't really endorse this item. This is sort of what happens with depression and suicide ideation. So even people who are highly depressed, they're in the, they endorse every other item, have a high score on depression, are still going to have a very low likelihood or a very low endorsement of a question about suicide or suicide ideation. So it tends to be a very low discriminating item, because there's not a big difference between those who are high in depression, those who are low in depression. Same thing here. These are high in social anxiety and low in social anxiety. The difference is not very much. It doesn't tell us very much about the difference. So if I gave you just this one item, I couldn't tell if you were high or low social anxiety. Right? This item doesn't really tell me that much about what group you might belong to, high or low social anxiety. Where this item, I can give you just this one item about avoiding people at parties, right? That one, if I give you that one item and how if you endorsed it, it'd probably tell me a lot about the fact you're probably in the higher group. If you didn't endorse it, it probably tells me you're much more likely to be in the lower group. It's much more discriminating in terms of where you might be on the overall scale, the traits of social anxiety, than this item does. And there's a lot of variability. This item is not very good in terms of discrimination. This item is pretty good, 0.707, 0.729 is pretty good, right? So there's a variety of items that are discriminating and not discriminating depending on how you look at it, depending on which, these are a couple items that aren't very good. They're low on discrimination because the high group doesn't look very different than the low group, at least not by much. Or up here, like this 0.729, the high group and the low group, there's a huge difference. So it tells me a lot about where you are in social anxiety by simply looking at this one question. And that one's about, I'm a very social person. I think it's actually reverse coded, to be honest, because for the fact that this one to be 0.777, for it to be social anxiety, this one's reverse coded. So it seems a little odd. So these are people who said no to this. These are the people that said yes to this. So it's flipped. Okay. Or sorry, these are people that said no to this. These are people that said no to this in the two groups. So the endorsement of the item is sort of getting flipped in the direction of social anxiety. So that actually makes sense. So the way you look at this is if I took, and there's, I don't know how many questions there are here. Let's say it's 20 questions. It's probably about that. And they're all 0, 1. If I were to add up all the 20 questions, right, and then I rank ordered everyone in terms of a score from 0 to 20, I took the people who had the third highest scores, in terms of the proportion of participants. The highest third is the extreme group is the one that had the highest scores. Then there's the middle scores, where there's somewhere probably around 10 or something, and those with low scores, somewhere around 0 to 5 or something like that, are in the low group. Make sense? So these people in the high scores are the ones that endorsed most of the items. They had a high rate of endorsement of all these items. But even if they endorsed most of these items, they still weren't likely to endorse this one. So even if I said yes to all the other items, I probably still didn't say yes to this one. I probably had a low likelihood of saying yes to this one too, right? Because even though I endorse a lot of the other items, I just like having people around me that was not very likely to be endorsed. So even if I'm high on social anxiety, I may not say yes to this question. Yeah, so you can see some of them are, I prefer to pass by people I know. Okay, so in this case, if I said yes, right, that indicates social anxiety, right? But not every question endorsement is yes necessarily. So I'm a very social person. Here, this one would be if I said no, that's social anxiety. So in that case, the high score, so here yes would equal 1, but here no would equal 1. Right? I like to go to parties and other affairs. Same thing. No equals 1. Make sense? And it's a weird one. See, like I wish I were not so shy is a tough one. Because people who are extreme and have extreme social anxiety, they know they have social anxiety, but they oftentimes don't, they wish they didn't. So if you look here, there's a lot of them that are saying, yeah, I wish I wasn't so shy, right? And this one, there's even, a fairly large, not a huge amount, but there's still some people, 12% of folks in the low group that are saying that they wish they weren't so shy. So this is a fairly discriminating item Because even though this is not directly about social anxiety necessarily, it's just about being shy, people with social anxiety do often wish they weren't as shy as they are. So in this case, even though it's sort of a different item, their yes does equal the 1 there. Right? That's if you endorse that, that's actually on the social anxiety side. Make sense? Like this one, I have no dread of going into a room by myself. So this, again, this means it's not the whole question, but it's going into a room by myself, meaning not into an empty room, going into a crowded room, like entering a party alone. So that one, having no dread, that means if you say no to this, that's your endorsement. So 68% of people said no, but only 12.5% of people said no. So it's not, massively discriminating, but it still does give you some discrimination. So there's a way of thinking about discrimination index from that perspective. From looking at the extreme groups, can it tell the difference between someone who's really high on all the items from someone who's really low on all the items? By comparing the percentage or comparing the difficulties in these extreme groups. It should be easier for the high group and more difficult for the low group. If it is, then the item is discriminating.